This is our global isotherm map, and it shows isolines that measure temperature. Doesn't matter if it's degrees Celsius or degrees Fahrenheit. We can see hotter temperatures or warmer temperatures are in the middle of the map, shown in red, and colder temperatures are shown in blue, and we can find those on the top and the bottom of the map. And so in the middle there, along the equator in January, it makes a lot of sense because the subsolar point is there in the southern hemisphere, so it makes sense there. Just below the equator, we're going to find warmer temperatures because it's going to be longer day length. It's also going to be higher sun angles, whereas then in July, everything switches. So we definitely see the role of latitude and the subsolar point moving back and forth in these isotherm maps for both January and July. And of course, with the movement of the subsolar point, we have these latitudinal changes, and it also relates to the hemispheres. And so the southern hemisphere is also the summer hemisphere during January, and then everything switches. We become, here in the northern hemisphere, we become the summer hemisphere where our temperatures are much warmer on this side of the equator during this particular time of the year. Now let's further look at some patterns we see, or some differences we see between the two different hemispheres. And this relates to land and water heating differences. So this relates very much to other topics in this particular section. And so we have two different squares or rectangles shown on here. So the bottom one in purple is essentially from 20 degrees south to 60 degrees south. And the yellow one is essentially 20 to 60 on the northern hemisphere. So it's those same latitudes but on opposite sides of the equator. But you notice a different pattern here. It doesn't matter if it's January or July. The January, notice how there's really not that much change in the one here in the southern hemisphere in the purple box, whereas the one in the yellow box has much more changing. It goes back and forth, slopes up and down. And we really see that in the July as well. And so see, once again, the pattern is pretty much linear, a little hiccup there, but pretty much as we go across, not much change in the isolines. Whereas here, you see big, huge changes. All this relates to the differences between land and water. And so we have the different heating differences, and of course, we've got one hemisphere, the northern hemisphere, that's overwhelmingly land masses, whereas the southern hemisphere is also known as the water hemisphere, and so it's also going to play a role. And so we see moderated temperatures, not much change, the role of water bodies as far as moderating temperatures, whereas land masses essentially cause things to go wonky and cause extreme patterns to occur. So of course it would make sense then that the coldest and the warmest temperatures we'd find on Earth would be in the land hemisphere, because of course, once again, land heats up but also cools down faster. And of course, what do we notice there in the yellow box? What I have provided is the coldest temperatures are found in eastern Siberia. And so we've got kind of this sweet cocktail of reasons why this place is so cold. First off, it's polar. Latitude plays a key role. We see that white dashed line is the Arctic Circle. So during January, places up in this particular area, and we're talking near endless nights, but also hardly any sun angle, if at all. So that, of course, latitude plays a role. Also, a little bit of altitude. There is some higher elevations in this particular area. But also, what we see is it's located deep within the continent. And so because it's deep within the continent, we're talking far from a water body, whether it be the Arctic Ocean to the north, or the Pacific Ocean to the east, or the way to the west, the Atlantic Ocean. And we're talking far, far away. As deep as we can go within a continent is there in eastern Siberia. Now this is much different than the summertime, where we have the hottest temperatures over in Africa in this yellow box. And so of course here we're going to have in the summertime the land's going to heat up super fast. And so let's go find an area that's located deep within the continent, and so we can find that there in Africa. That's also latitudinally at the right location. Now why not at the equator? Remember, we talked about the equator there has that dense rain belt, that cloud, all those clouds and water vapor. And so in the case of the Sahara Desert, there's no clouds. So the absence of clouds, but also being in an area where you have very high sun angle during July, but also consistent day length for a pretty long day, combined with the fact that you've got that sun just comes screaming through the atmosphere with nothing blocking its path. No wonder here, located deep within the continent of the Sahara Desert, we have the warmest temperatures we'd find on Earth.